out there, thinkers, linkers, and mappers. We are very happy to host a series of conversations around the topic of tools for thinking. Our longer-term goal is to spark a diverse, connected, shared memory that will help us make important decisions together. Our near-term goal with these podcasts is to interest startups in being part of BetaWorks' upcoming accelerator, Think Camp. BetaWorks is a New York City-based incubator and accelerator. They've run 7 camps before on topics from bots to synthetic media and voice interfaces. You can find out more about BetaWorks and the Think Camp and this domain by going to betaworks.com/camp. I'm Jerry Mikulski, your interlocutor and obsessive mind mapper. Our topic today is machine learning for thinking. It's going to be really cool. It's our first peek under the tent of machine learning in this little sequence of podcasts, and I'm really excited for the topic. And my guests are Albrecht and Sam Arbesman. We're staying in the A's for this episode. Alice is the founder of Recollect, and Sam is with Lux Capital. And as I tend to do here, I will ask you each to just sort of talk yourself into the topic. Alice, how did you find your way to Recollect and this crazy little tools for thinking space?
Yeah, well, thanks for having me, first of all. So my background originally, I was an academic, actually. I was in cognitive neuroscience. So I have spent many decades now thinking about the mind, somewhat about thought, but lots about the mind. And then I've spent about a decade in tech then after that, doing data and machine learning work in various settings and various ways. So Recollect for me, when I sort of set out to found this company, was a way for me to kind of combine my interests and what I thought would be the future, what was coming next. So I spent about a decade doing machine learning work in tech in various different roles, and then bringing those together. When I set out to start a company, I was really looking at something that was a combination of the things that I've been really interested in for a long time, and also where I saw the greatest potential moving forward. So for folks that haven't heard of Recollect, I'm the founder of that company. And what we do is we are trying ultimately to augment your memory and creativity as humans. We do that to start by taking all of the things that you read, notes you take, and bringing those to you automatically when you are ready to work with them. So if you are ideating, so putting your ideas together, if you want to understand what you know about a topic more deeply, and better yet, if you're creating something with that. So if you're writing a newsletter or a tweet, even, we want to be there for you to let you utilize your electronic memory, as it were. And so, bringing all these things together, Recollect is really for me, a passion. And I think that is a direction that we're heading more generally in terms of people needing their creative thoughts to be ready for them.
Mm-hmm. Thank you. And you were on a great panel for us at the Render session a few weeks ago in New York. And I felt like you were giving us kind of a cook's tour behind the scenes of what somebody who's deep into the algorithms and the capabilities of the machines already assumes as possibilities, limitations, and all that. And I want to come back to that for a second. But I think that one of the influencing factors for Recollect is the extended mind thesis, the idea that there's sort of more than just what happens inside one cranium that's manifest in many different ways. Do you want to just riff on that for a second?
Yeah, I mean, the term can be really specific, right? So Andy Clark did a lot of this work, and we can think about sort of that work earlier on or in the realm of psychology, but it's been used a lot outside of that as well. So I feel like at a general level, what we're talking about when we talk about an extended mind is having even, as simply as a sheet of paper and a pen. That is an extended mind, right? So you write something down, you've externalized your memory, it is there for later. There are lots of criteria for that. But some of the criteria are that you can reliably use that again, right? So I could write something down, but then if I throw it away in the garbage, it's really not an extended mind anymore. So when I talk about an extended mind at the highest level, what I'm talking about is, are we able to not even just offload, but sort of co-work with our thoughts outside of our own heads?
Mm-hmm. And how much of that is about collaboration between humans, and how much of that is just the extended mind for the individual out into media and artifacts for you?
For me, it's more more about the individual. But if you think about the way that we're even talking right now, I am putting my thoughts and ideas out verbally, and you're picking them up and you're translating them, and kind of we're having this back and forth. So I do also think a lot about in conversation or as you read people's work, right? If as you are influenced by other people, um, and you put that back out into the world, I think about it in that sense too, of sort of externalizing that process.
Thank you. Makes great sense. Sam, you're with Lux Capital. It sounds like a light in the capital world, but I'm not sure that you're in the lighting business. So what does Lux do?
Lighting business. So Lux is it's a venture capital firm that invests in like emerging tech companies, or I guess companies that are kind of playing with science fiction ideas, trying to kind of bring things from the science fiction world into science fact. And so my own my own path into this. I also got my start in academia. I have a PhD in computational biology. Got my start initially in evolutionary biology, but then quickly moved more into understanding complexity science, kind of trying to understand big complex systems, whether or not they were in biology, whether or not they're social systems or technological systems. And obviously all these systems are different in their own special ways, but there are ways of abstracting the details away and actually finding certain mathematical and computational regularities behind all of these. And so, and one major area is that of network science, trying to actually understand the relationships between the pieces of the system and how they all interact. And so I kind of moved more into network science, got very interested in interdisciplinary research, trying to find commonalities between different areas. And so after kind of spending time in academia, spent some time in the foundation world, and then eventually found my way into Lux. And so I'm their scientist in residence. And basically my role is to survey the landscape of science and technology and find areas that could be of interest to Lux. And sometimes finding companies, finding people to build companies around, connecting the areas I'm exploring to our portfolio of companies that we've already invested in, and sometimes just engaging with the public through writing and speaking, or connecting to various communities that are maybe not as connected to the venture world or Lux, and kind of bringing them into the orbit of Lux. But what that means, though, is kind of on a regular basis, I spend a lot of my time thinking about a new thing every hour or every few hours. And I'm really interested in kind of where the intersection of ideas happen, and kind of where different domains and fields collide together. And so I guess, so in terms of my interest in a lot of these things, I guess it's both professional in the sense that I'm always trying to find new and interesting things to try to connect them together and kind of find different areas. But it's also from kind of my roots in complexity science and network science, which is how can we better use kind of the science of how different ideas are connected or people are connected, and navigate this kind of high dimensional space of ideas or people or papers, whatever it might be. And so I think a lot about how can we build better tools for serendipity or finding new interesting ideas, and both in terms of helping me find interesting things that could be of relevance for Lux, but also just because I think we need better tools to allow better innovation and more innovation to actually happen.
And I just have to say, it is such a juicy moment in human history to be doing what you're doing, and both of you. I mean, like we have superconductivity of ideas, publications, people. We're sitting here on a nearly zero marginal cost, very nice resolution and audio quality Zoom call that we take for granted now, which, a couple decades ago would have been like, how are we going to do this? And then there are so many people doing interesting work where the experimentation is their time, but there's these insane power algorithms just lying out there in the field, so to speak, for people to tap into. So partly I wanted to start with a little bit of just what is currently under the machine learning, machine intelligence umbrella. What are the kinds of both from a technological perspective, but from a what problems are people solving? And the ones that are easily visible are deep learning in different senses. Some piece of that is turned into text to image generators. So the DALL-E 2 and other sorts of things happening. And now there's like a half dozen of them, changing what we think of how painters and artists are going to work. And if you're a painter or an artist, you're scratching your head going, wait, Doom? Is this bad? Photography was going to be bad, but it turned out okay. Before, a little digression, but before photography, the representation of a battle was some painter who was told what happened on the battle and painted a heroic image of the battle collapsing in time and space, because they wanted to show when the hero died and is bleeding over here in the arms of his lieutenant, and over here the charge of the cavalry, and back there the castle that was stormed, none of which necessarily sort of coheres or makes sense. And it isn't until Matthew Grady takes pictures of the battlefield at Antietam with bloated bodies lying in ditches that the American public sees those in newspapers and goes, oh, wait a minute. Like battle is not glorious and wonderful. Battle is dangerous and disgusting. And there's lots of dead people here. And I'm sitting here thinking, okay, that was one of the spillover effects of photography, which is a while ago, right? 1860, 50, somewhere thereabouts. And now we're talking about, I think, things that are at least as dramatic and different and interesting. But I'm curious, what's in the tent? And there's also text generation, the image generation, text comprehension, similarity seeking. How do you look at the bag of tools? What's in the toolkit?
Bag of tools is very interesting. I like that you started with deep learning, because I feel like people have forgotten about it now. They're like, oh yeah, I don't know.
Such a shame too. I really like deep learning.
Well, yeah, I mean, I think it's not even that deep learning doesn't exist anymore. It's not like we've replaced it with anything. Really, it's really imbued in all these other things. But the problem with deep learning was you needed so much labeled data most of the time. It was a thing that was difficult for people that didn't have lots of computational resources to actually use. And even those that did, finding a use case for it that was really going to be applicable inside of an organization. I mean, we were talking right before this, like I was at Fast Forward Labs for a while. We worked a lot with big companies and little companies too, to help them understand what they could do with things like deep learning. Deep learning is definitely still under the tent. I think that there is, anybody who's been on the internet recently, or Twitter, or these places, probably this community listening to this, has seen the really, really interesting demos with natural language generation, natural language understanding, and now the multimodal models, right, where we're getting images and text and we're crossing over those things. I personally am very excited for the multimodal piece. It's something I've been advocating for 5 years or so, trying to get somebody really excited about it. As somebody from the sort of cognitive neuroscience space, it feels really obvious that we start to combine these things. So those are certainly under the tent. I think there are lots of other tools and techniques that don't get as much attention, I guess. And I think some of that is research interest. So the people that are creating these things, and some of it is like how much of it is publicly available and easy for people to pick up that are not necessarily machine learning researchers. Today, I think for the average person trying to implement something with machine learning, we still have less complicated models that you can use for things like, fraud detection. You don't need a DALL-E or something like that. So there are lots and lots of use cases where people are using machine learning today. It's invisible to the end consumer, but it is powering a lot. Recommendation systems are something we've become completely accustomed to, but that's generally a machine learning model under the hood.
It's really interesting because I have a funny connection to this field in that my first job in tech was back in 1991, and I joined a little company called New Science Associates in South Norwalk, Connecticut, and I joined their AI service, and I became their neural networks analyst. And deep learning is called deep because it's multi-layered neural networks. And back then, what I was doing was explaining the difference between rules-based systems and neural networks, and how this one can explain to you which rules are fired, and that one over there cannot. And this could become a problem, but blah, blah, blah. And there's all sorts of really interesting issues that come out of that. And back then, there were other things like fuzzy logic and case-based reasoning. And there were all these other things that didn't really make it through, right? But we were writing about them. We were interviewing the companies that did them. And I don't hear much conversation now, for example, about rule-based systems. Either they got so mainstreamed and they're just sort of vanished into the background, or they didn't make it, or I'm missing something. Like what, for example, what happened to normal, what we used to call expert systems?
My sense is that and I could be wrong about this, but I feel like IBM Watson included some sort of expert system piece within what they were doing.
IBM was like a polyglot mashup of a bunch of different kinds of systems.
In my sense, and like more broadly, there's like the whole like symbolic approach. I think the symbolic approach, and obviously, it's not on the rise right now, but I think a lot of people, or I wouldn't say a lot of people, but my sense is that there are a number of people, a number of researchers who think that to kind of take some of these ML techniques to kind of build next level, some of these more symbolic approaches need to be combined with them. I feel like, and Gary Marcus, I think he often writes about this kind of thing. So I would say he's probably the most prominent proponent of kind of advocating for, or at least recognizing the importance of symbolic approaches alongside some of these other things. So I think it's not gone, but it's maybe kind of either been incorporated into other things, kind of in like alongside like the Watson approach. With my sense is, yeah, it was just a lot of things that kind of threw a lot of things together and kind of hoped it all worked out. And then there's other people who are kind of beginning to revisit some of these. Alice, is your sense does that accord with your sense of all these things?
I think so. And I like whenever I'm on a podcast to like make a bet, and then, years later, I'll listen to it again and see if I was right. I'm sure I made a bet on the multimodal piece. I think we're going to see a combination of these as people like right now we're talking about just machine learning. How can we apply it and like kind of put it into a system? There's a whole group of people that like to talk about AGI, and I don't think we should take that left on this podcast. But, sorry. But I think that when we start, like, Gary Marcus, I think Tannenbaum's lab at MIT, like, there's these people that think a lot about, like, how do we have symbolic systems, non-symbolic systems at sort of like a less technical level? Like, how do we start to, like, have things that we can bake into these things that we already know, right? Like physics, right? Like there's laws of physics that we can start to put into these models that don't need to be learned by like lots and lots of trials necessarily, right? Like, so we can refine those, but there are pieces. So my take is that, like, yes, I agree with your account, Sam, of that this is sort of where we're at now. I think we will see a resurgence of adding things in intentionally that we know to be true in the world. And I think some of that will be driven by the folks that really are trying to shoot more towards an AGI. These would be the same kinds of folks that want to like teach this as they would teach a baby, right? They're looking at the ways that babies learn. They're looking at lots of different Bayesian algorithms, but they have a really different focus, I think, which is very interesting in the machine learning space from someone who's like, I want to create art with this, or I want to like make a better risk model.
Yeah, I would say in one area that I think is also beginning to become like I wouldn't say a resurgence because I don't think it actually truly went away, but like the whole space of evolutionary computation. It was very popular in maybe like the 90s, early 2000s. And then with certain other, like the advent of other techniques, it kind of couldn't quite compete in certain optimization techniques. But I think now with just so much more computing power and data and processing power, they are able to do certain things. And so, and especially the interesting, so one is I've seen this kind of being used in tandem with other ML techniques. I think it's sometimes for optimizing hyperparameters and things like that. But in addition, the interesting thing with evolutionary computation is that it can, at least in the genetic programming kind of version, among others, it involves manipulation of symbols. And so you can actually pour in a whole, and going back to like what you're talking about with physics, you can just pour in a whole bunch of data and say, provide some equations that actually explain this kind of thing. And my sense is in certain cases, there have been situations where these systems have popped out results and the scientists are not entirely sure, like the formulas work, but they're not entirely sure why they work. So it's kind of, so it's an interesting thing where there's, sometimes the deep learning techniques have a certain amount of non-explainability, but even sometimes the more symbolic approaches might also have that as well, which is kind of interesting. I don't know where to take that, but it's intriguing.
And I think you said in your intro, you at some point were on sort of evolutionary biology. Yeah. So evolutionary algorithms and machine learning are nowhere or the last time I looked into them, were not nearly as complicated as evolution probably is. But they take some ideas from that, which is really interesting. And I think the sort of applied place I saw this there, I think Uber was doing this, or some folks at Uber were doing this, and maybe out of the University of Austin in Texas. This was a few years ago now. One thing to loop this back to our conversation, though, with the evolutionary algorithms that I really loved when I looked into this was that sometimes they'll introduce sort of like random, or they'll bias the models towards like really a little bit more aberrant, like the next generation that it breeds. For me, I think when I sort of went through how the algorithms were designed and why would you do that, right? Like if you're trying to get to a specific thing, it's not a great idea to introduce lots of, chaos into the system. But if you're looking for more creative solutions, that's very interesting to me. So like the idea that you could have this style. So in evolutionary algorithms, you have generations of these algorithms. And so as somebody who is really excited about, creativity and machines beyond even like painting things and making text, I think it's very interesting to start to uh, think about how we would bring that in to evolutionary algorithms when we think about things. But yeah, just generally, I love that about them.
Yeah, so I think you might be talking about like some like the like novelty search kind of algorithms, like that I kind of are and where it's like the I guess the thing you're selecting for.
The objective,
The objective
Objective
function, or rather than it being some sort of objective, it's just more, okay, is this new in some dimension or some way of explaining it? And so like so Ken Stanley and Joel Lehman,
Yes.
who I think, so they worked on some of this. They have a book called Why Greatness Cannot Be Planned. And their whole idea is like when you are searching in some massive high dimensional space, then it becomes very hard to say, okay, here is a specific thing we want. Rather, instead, the idea is to just optimize on interestingness or novelty or creativity. And the idea is that what that will do is will create a set of stepping stones that can then all be recombined in some sort of productive way, and then will yield kind of this like expanding boundary of interestingness that then will hopefully get you eventually to the objective that might be very hard to actually otherwise describe or formulate. So yeah, and I think and it goes very well with like tools for thinking of like how do you optimize for interestingness and like find the kinds of things that people want to actually be shown, or the kinds of things that are going to be most useful for actually generating new ideas. So yeah, no, you're that intuition of going in that direction is exactly spot on.
I love that. And I love sort of the mixing and remixing of ideas and technologies that's happening that you're both really fascinated by, because I love that as well. I want to scroll back for a second and ask a question explicitly that we kind of looked over the fence at, which is, do either of you think that computers or software can be creative? What does that mean for you?
I guess I would say yes, in the sense that like creativity, I think, is like a combination of like there's like novelty and surprise, but like it's like novelty and use, or maybe like surprise and usefulness, or I'm not really sure of the right combination, but maybe it's one of those kinds of things, like it when you see it. I do think they can be creative. At the same time, though, I would say, and there is kind of the view of like, oh, like these MLTs, they're just like stochastic parrots. They're kind of like recombining things.
Exactly.
Or at the same time, though, and that is certainly one really important component of creativity, which is recombining and remixing. So I would not say that machines and computers can be creative in all the ways that humans can be creative, at least at this point, but certainly in some of the ways that humans are creative, I think we're there. And that being said, I would say it's the kind of thing where yes, and machines can be creative. At the same time, though, like whether or not that's a cause for worry, and this might be hopelessly naive, but the way I kind of view it is like, humans have still made these systems, and so we can kind of take a certain amount of pride in that. Kind of the way I view it is there's this Yiddish term called nachas, which is kind of like vicarious pride or joy in the accomplishments of like your kids, or like when they I don't know, when they like have their bar mitzvah or get married or go to college. Like it's not your own accomplishment, but you can still take a certain amount of pride and joy in these kinds of things. And I feel like we should be having more nachas for our machines in terms of their creative abilities. I would say they're maybe creative still in somewhat simple kind of like stumbling ways, the same way like maybe like small kids are kind of creative, but they're also like when you kind of, and like I've had situations where like my kids will come home and like show me something that seems really, really creative. And then when you start asking them, like you kind of realize that they sort of took something that I didn't know about and then kind of just like tweaked it a little bit. And so it seemed like it was entirely novel, but it was less novel than I expected. That being said, they were still being very creative. And I don't want to shortchange what they were doing. And I feel like that's the same kind of thing with machines, where yes, we can caveat away all the accomplishments of these machines and these computer programs, but they are still at some fundamental level being creative. I would not necessarily say they're more creative than humans, but they are certainly creative in some vague sense.
Cool. Thank you, Alice.
Yeah. I loved your answer. I have what sound at the surface like some conflicting ideas about this, I guess. One thing I would say, just riffing off what you just said, Sam, was, are they more creative than humans or not? I think that's maybe the wrong question. It's like they have a totally different kind of creativity, and that's fine. Like when we're trying to design these I don't think the goal has to be, let's get to human level X or beyond it. And so when I think about these algorithms and creativity, I think when we define creativity, the way I look at it is from a psychological perspective, or a psychological testing perspective because of my background. And so I kind of can't help it. But in cognitive science or in psychology, when we think about creativity, when people test your level of creativity, what they're testing for a couple of things, like, can you come up with novel ideas? So those are things that maybe didn't exist before, either for you or for everybody else, which is an interesting distinction.
Mhm.
And are they useful? So are they grounded in something, right? Like, I could create an algorithm that just took two things and squished them together. And maybe there's millions of them and they just squish them together. But that's not creative if it's not useful. It's not grounded in something. Not that all creative acts need to be useful, but there's a context and there's something that either the human is trying to convey if they're doing some creative act. Or when we talk about machine creativity, like, we're missing this intent piece, right? Like, usually there's some human behind it that designed the algorithm, of course, but also is deploying it and putting it in a setting, right? Like, even if I use these new algorithms like Stable Diffusion, I'm writing a text prompt, right? I'm giving something to the machine. I think where this starts to get really interesting for me. So if we take that kind of working definition of creativity, I think we could program machines to do that type of creativity, right? And that's something that I think about a lot for our product, and sort of the work that I'm doing now is, if the name of the game is to help people come up with, creative ideas, can we, like, create this artificial serendipity? Can we take things that are connected but not quite right on the nose when we bring them to them? But the way they're connected, I think, is really important. So machines, I feel like, if they're being creative, they're programmed to connect things in certain ways. And humans connect things in lots of different ways. Like, I think, did things happen around the same time? Do you have some, like, disparate memory from a long time ago that you're connecting and you're bridging all these things? That's much harder for machines to do. So I think machines can produce outputs that would meet the criteria for human creativity. But I think that right now we're not quite there where we would say, oh, they're just being creative on their own. It's more of this symbiosis of, human creating a thing, machine doing, creating some version of that, helping them. And going way back to the comment about kids, I have children also, and I feel like sometimes I'm like, oh my God, you're a genius. Look at this crazy thing you came up with. And but there is usually something underlying that. And I think that's true with all humans where, they had some spark of inspiration. They attended to that thing, like somebody said a word or they thought of something, and then they're kind of building on that. So when I think about creativity, I also think of, like, it's building on other pieces that are already there.
We're
There's
pretty good
always
at
these,
remixing what's in front of us. Sorry, Sam,
Right.
go ahead.
Yeah, I was gonna say, yeah, there's always raw materials. Yeah. And to what to your point, Alice, like, the question is whether or not the computer is remixing these things on its own, without a prompt, for something that actually is kind of creative, like feels like useful or valuable in some way. And you're right, like, we're still not quite there. It's much more of like a human machine partnership as opposed to just kind of like allowing these computers to go off and be creative on their own.
And sort of to just walk back and pull evolution back into the conversation, evolution is creative. It's just that it's stochastically creative, and the things that don't flourish die off. The things that flourish look really creative and, in fact, create new niches or dangers for us, et cetera, et cetera. We're watching that at work with the pandemic we've just been sitting through in Zoom, like locked into little Zoom rectangles. And then there's a whole bunch of interesting research over in Evo, Devo, and all these different areas. I don't know how much of it is making it over the fence into large language models and deep learning and so forth. But I'm very intrigued by that because, like you both, I love the multidisciplinary, the nexus of innovations coming from lots of different places makes me really, really happy. Are there places you've seen where we are overestimating the capacity of machine learning? Are there things you've read where, like, no, we can't do that? And if so, what areas would you mark off with yellow tape?
Yeah. So one area that's really, I guess, salient right now, is these large language models and is all of this text that's being generated. And I think it depends on the person and really their background and what they're trying to get out of these. But I think it's easy to overestimate what those large language models can do and what they are doing. I think that they're fantastic, but I think that it's probably going to lead us astray if we think, oh, they deeply understand, right? They're the understanding is something we don't understand because it's not super easy to inspect these models. Those models are created in isolation. So when humans learn things, right, we're in an environment. So we're getting information in, we're updating things, reinforcement models, follow this paradigm. But large language models on their own don't really. They learn regularities. There's lots, if it's a mass language model, it's predicting the next word. It's got lots of data. That's fantastic. No human probably could read all those books and all that text and pull out all that data.
It's crazy.
It's crazy. It's crazy and it's fantastic.
Yeah.
But I worry that we're overestimating in that sense, like how much these models really understand, and what's possible from that standpoint. Like if I believe the model understood everything, like, oh my God, there's so many things it could do.
Yeah, like the understanding piece, I think, is still something that it can simulate a feeling of understanding somewhat reasonably well, but we're not there yet. And because of that, we have to make sure we're using these tools like kind of with that understanding of, or with the understanding of the lack of understanding in mind. And so, like, for example, I'm very interested in kind of like alternate history stories, where it's like, oh, like what if something were different in history? And so I started, I was kind of feeding some like summaries, I think based on like Wikipedia summaries of like novels and books and movies and things like that of alternate histories, and giving them to GPT-3 and saying, okay, now I'm going to give you like a new what if, and kind of seeing what happens. And like the outputs of like, oh, like what if Jimmy Carter were reelected or whatever, and kind of seeing that kind of thing. And the summaries that came out were not terrible, but they also belied this like clear lack of understanding of the world. That being said, though, because these large language models have this like massive matrix of associations of different concepts, it's actually really good for helping, like I guess in terms of like divergent thinking, or kind of like helping saying, okay, here are the kinds of things I need to be thinking about. So like when I try to understand the world, what are the features that are actually salient? Because too often I feel like we have so many biases that we forget all the different things that we should be considering. And these machine learning techniques, and they have many biases in their own ways, but sometimes they can help you kind of expand the set of things that you should be considering. And so I think even without that understanding, they can be useful for helping your own understanding. But you're right, you want to make sure that you're like very clear on the fact that they cannot understand these kinds of things.
And we humans are such good salience detectors that often our salience detectors throw away things that we ought to be paying more attention to. We dismiss evidence that doesn't fit our filters or our biases or whatever else. There's plenty of research in that area, but it's really interesting. And these computers are just kind of innocent. They're like, woohoo. The thing I point to when talking about the creativity question is AlphaZero, where AlphaGo beat Lee Sedol, the world's top-ranked Go player. Awesome. Then they said, well, let's not train this thing on all the Go games we can find, played by champions. Let's just give it the rules of Go. And luckily, the rules of Go are 19 lines by 19 lines, black and white stones, and here's how you kill something. So they're really simple. The domain is incredibly constrained. But then there's a chart that blows my mind where you watch the performance of AlphaZero blow past Lee Sedol, blow past AlphaGo, and there's a piece at the end where it's above whatever anybody's doing. And I say that right there, that's creativity within the boundaries of the rules of Go. It was inventing things that ages of Go player, maybe 4,000 or 5,000 years worth of Go players hadn't discovered to try to do. And that's very interesting. And Go scholars are busy studying those new moves and trying to figure out what that means. And I was just before this call looking at the cheating in chess controversy with Magnus Carlsen resigning from a chess game, and what's happened with chess software and all of that with freestyle chess. There's sort of like a mess in that space that's really, really interesting. And I think good fodder also for the kinds of things we're thinking about. Let me step over for 1 second, because like you're actually like neuroscientists. I have this feeling in neuroimaging and all the research on how we can see what we know and all that we're really working with 8-bit graphics, and like it's really Minecraft. It's worse than Minecraft images that we're getting. The brain is very loosey goosey, and things move, or things actually shift around in the mind and stuff like that. So if I were to point to places that I would rope off, I'd be like, we really don't understand how the mind works as nearly as well as a lot of these papers coming out would seem to make us think or want to claim to. Does that sound reasonable?
I'm going to deconstruct you before yeah.
Okay.
Lest my old advisors, come back, come at me. Which paper are you talking about? Machine learning papers? You're talking about cognitive science papers or neuroscience papers, or like?
I'm talking about what winds up hitting the news in Science Digest or wherever else. That, oh, look, we can mind read now, or we can place memories into people's heads, or we can whatever. Right. There's a bunch of things like that.
Yeah. So I mean, like if somebody said, "Oh, I can read your mind," or I can put false memories in your head, they'd say, like, okay, that's science fiction. That's not happening right now. I think that when you talk about like 8 bits or pixels, I mean, part of what comes up for me is like the resolution of the images, right? So we're seeing these images of the brain. That resolution they're called voxels. And I mean, we're trying to image this system. And what that represents is a population of neurons. So already we're at a place, depending on how good or how much resolution we can get, where we're getting information about a population of neurons if we're doing non-invasive neuroimaging. So it's correct in the sense that we're not getting to individual neuron recordings unless we're doing invasive techniques, and then we are. But we're getting them in a really small part of the brain, and it could be somebody that has their patient, their patient and that other things going on. So I think that the other piece of what you said was, you kind of use brain and mind interchangeably. I think they're really separate. So I think that distinction is really important. What we think about as the mind, I am on board with saying that it's contained within your body, really. Like, I don't believe, anything farther than that. But understanding the way the mind works is very different than understanding how your brain works. So I think those two come together. Obviously, I was in cognitive neuroscience. That's bringing those things really explicitly together and saying, okay, these models of the mind can be informed by what we learn about the way that your brain works, but they're informed by lots of other things, like your behaviors and psychophysical testing and things like that. So I think that we have a ways to go. What's very interesting for me is the interplay now between these machine learning techniques and neuroscience. And that unlocking a really new things that we can do. And when you add language into that, like back, a while ago, when I was in graduate school, I took a course in, I think it was called computer modeling or something at the time. This is like 2008, maybe. But, it was taught by a psycholinguist, and we learned about these like language trees. And I thought, oh my God, this is horrific. I don't think I would ever work on anything to do with language because it was so arduous. But when we think about combining, again, cross-disciplinarily, right, we've got these neuroscientific techniques that unlock a lot with neuroimaging. So one really interesting thing that happened, about a decade ago now, was that we started to be able to predict what people had seen, right? So if I am feeding all of these images to you and I get a pattern of activation, this was back in the day, then we were using this sort of multivoxel pattern classification to say, we can guess based on this neuroimage what image you saw. And that felt like it unlocked a lot. And I think it's gone from there. But if we take the sort of how machine learning is interacting with the neuroscientific models, and we're getting better data, those sensors get better. But also now with the language piece, I think it's very interesting. Because we can sort of do some things around, language is a little bit harder. I was more on the vision side, like it's a little bit easier to understand in terms of the biology of it, right? We have a visual area. It's pretty well organized. We have a good explanation or working theory around how this stuff flows through. Language is much messier in my mind. So when we talk about thoughts, like somebody like interjecting a thought into your mind, like where does that thought go? It's a complicated network of different areas that come together to bring up, and it's not even a thought, it's really a memory or the production of something. So I don't know what your question was now, but something to do with like the resolution of these things. I think it can look really like it's at a sort of a gross level that we're like, it's really brainy and we don't really know much. I think we know a little more than that, but I don't think we're in a place where it's, tomorrow I'm going to say yes. And I'm very much an optimist in this space. I love neurotech, but like, I don't think we're going to be saying like, I'm going to alter this memory for you, and just like fix it a little bit. So,
Arnold Schwarzenegger will be very sad about that.
yeah.
And thank you for indulging me in these excursions, because we're still sort of talking sort of neuroscience and algorithms and all that kind of thing. And I was trying to explore the boundaries, and sorry for my sloppy use of language. You're totally right. I was just flipping back and forth between brain and mind. But I'd like to take us sort of toward the entree for this conversation, which is, where does all this stuff that we've been turning the soil in affect tools for thinking? And what are the opportunities? What are the places where, we could start, Alice, with sort of the pieces that you're using and finding success with in Recollect, but where else? And kind of want to figure out, what does the horizon look like for the things that are possible? And I think there's lots of interesting things. I know that in my daily use of the brain, I would love to have a smart assistant sitting next to me going, "Oh, Jerry, looks like you just put a book in your brain. Would you like me to tag it up with metadata as a book and its author as an author, and find, her other books and add them for you?" And I'd be like, "Thumbs up, you bet." Because right now, all of that is manual for me, and that's a kind of assistant, machine learning informed assistant that would be completely brilliant. But I'm interested in more about this space, partly so that we can find the other players and see how this stuff all fits.
Yeah. So I think the world that you drew out, Jerry, where you have this assistant and it's helping you do these things, like you and I have talked about this before, but for everyone else listening, I think the path I think we should move is a little bit off from that. Like, I think that with machine learning and with not even just machine learning, but interfaces that are like changing in all the time, we have an opportunity to move beyond an assistant that would be able to tag things for me and sort of like organize them more nicely, which is great. I think it's a stepping stone. I think it's a really it's a useful thing to have. But I, for Recollect and otherwise, sort of want to blast past that, and have a system that can be a lot more flexible. So there's no hard coding, right? If we think about the mind and how they inform these tools, right? Like, so you have lots of things that are associated for you, but they aren't hard associations. So if I stick two things together, they aren't just stuck there, right? Like, those change over time as we have more conversations. You and I have had a few. All of those associations that we think of as like, okay, if I tag this with this thing and I organize it this way, then I'll be able to find it. Maybe. Yeah, there's evidence against that in some cases. But what I think a powerful thing in these new tools would be utilizing the fact that these models can adapt to sort of changing environments, right? Like, the things are changing, they're evolving over time. It's learning more information, and it's changing representations in ways that maybe the humans don't need to see all the time. So I don't have a physical piece of paper, or I'm not looking at two books and saying, I want to see those two things together. So I think there's a lot of opportunity there. And that's part of, of what we're building at Recollect, and what I'm interested in there is, can we start to automate some of these pieces that I don't think people need to actually do? They're just a sort of crutch in the middle, that we've used in these physical spaces. But then the other side of that, which I think will, continue to be really interesting, is can we not only organize those books for you, Jerry? Can we start to like suggest how they're connected, right? In this vast space of possibilities that we talked about, you had said, I think, people are really good salience detectors, and I would say, yes, and they're easily distracted, and it's hard to keep all those things in mind. So that goes back to your memory. So if your working memory is limited, if I put these two books together, it'd be great if that assistant can also kind of suggest, again, how they're related, why they're different, what other things. So I think there's a lot of possibility in the tools for a thought space, coming back to that, for us to use these algorithms in ways that are not just automating the process that we're already doing right now.
Mm-hmm.
So I'm super hopeful for that area.
I agree entirely. And thank you for sort of shining a light on the fact that my use of this tool is so manual that I would be happy to have minimal assistance to do something like tagging, and which is the example I gave. And it's clear that there's so much more possible. And it's clear from where I'm sitting chugging away with this simple tool that I'm not seeing that, because I would just like that next little step. And what I really want is what you just did, which is, okay, like that's great. We can do that. What's next? What's out there? And Sam, if you want to sort of take a swing at framing this, please.
Yeah, and I think of it a lot from like the perspective of like when you have, and as a society, huge amounts of information, more information than anyone can ever consume. I mean, even within the sciences, like not only can you not know all of science, you cannot even know your own little tiny specific subspecialty that you might be trained in. There's just too much being generated. And so the question becomes, what are the kinds of tools that can be used to kind of help navigate this, help make discoveries? And so like one of the earliest examples of this, of like someone trying to grapple with this, was actually it was in the mid 1980s. It was the information scientist Don Swanson. He wrote this paper called Undiscovered Public Knowledge, and the idea behind it was kind of like, he started as a thought experiment. Essentially, he said, imagine there's some paper in the literature that says A implies B, and there's another paper somewhere else in the literature, maybe in your specialty and somewhere else entirely different, that says B implies C. Because the literature is so big, chances are no one's ever read these things. And so even though it might be true by combining them that A implies C, no one knows this. And so at the time, he actually used like manual search tags, I think in like Medline databases. And then he found a relationship between, like consuming fish oil and actually helping alleviate some sort of circulatory disorder. And then he published it in a medical journal, even though he had no medical expertise. And since then, though, we now have ways of automating this. And so actually, in the past few years, there have been papers that have taken the literature in a specific area and then done sort of this kind of like word embedding, kind of put it all the knowledge in some sort of latent space, and then said, okay, where are the different concepts? Where do they lie? But then not only that, can we actually figure out like what are like when these discoveries were made, like when these advances, let's say in material science, were made, but based on these embeddings, could we have actually made those discoveries earlier? So like if like we know when the paper for some advance happened, but based on all the previous literature, if we had poured it into these kind of ML techniques, could we actually look at that space and find where these gaps were or where these connections should have been? And it turns out you actually can do that kind of thing. And then, so there's people have actually also done similar techniques of helping to try to predict which papers are going to actually be the most impactful earlier than it eventually became clear. There have actually been a number, and there's this nonprofit organization called OUGHT that is working on a tool called Elicit.
How do you spell it?
Yeah.
So OUGHT is like kind of like OUGHT.
OUGHT. Okay.
Yeah, like what ought to be done. And then so the tool Elicit it's based on kind of like GPT-3 and some other large language models, helps you actually navigate the scientific literature. And I'm saying this all from the scientific literature space, but I think these kinds of tools are really valuable. And so one of the things that Elicit does is you can ask it a research question. It will show you a whole bunch of relevant papers to that research question, but then using these large language models will actually help summarize the findings and help summarize the finding relative to the question you had. And so we're beginning to see a lot of these ML techniques help us stitch together all the knowledge that is out there that no human can ever possibly know and actually bring it all together. And so I feel like we are helping discover all that undiscovered public knowledge. And so I'm very hopeful for what the future holds here.
I love that scenario. And I think that properly applied, a lot of these things are going to be really fruitful in the next couple of decades. I mean, it sort of has to be that way. And then in the back of my mind, I'm hearing the song "Skull Crusher Mountain" by Jonathan Colton, which is about a evil mastermind who welcome to my lair here on Skull Crusher Mountain. I'm like, man, I hope that the darker side of people out there doing stuff don't get there first, because it's really powerful, right?
And I hope we don't get to the darker side of things. I will just give a tiny plug for Elicit because I've tried it and it's pretty neat. For even putting together these ideas to create more things in Elicit, I'm sure. So that's really like a already here today thing too.
Right. Yeah, we're there. And
we're there.
I mean, and yes, and to your point, Jerry, of like a lot of this, like the ability to kind of speed progress and innovation is very much a double-edged sword. And at least my hope is that we are going to make good advances faster than people can kind of use them for bad. And I think that's more of a hope than necessarily a truism, because and we don't know. But I'm hopeful that these kinds of tools will help us kind of better advance the frontiers of knowledge, rather than just
exactly
democratizing mad scientists or evil geniuses or whatever.
I love that. And it sounds like we're sort of lifting the lid on a topic for a future podcast episode, because I think the idea of good AI, friendly AI, ethical, moral, whatever you want to call it, how these things work, both when you send off the machines and they start to do things autonomously, but also when they're tools for thinking coupled with humans. And what does that mean? How does that work altogether? So we can set that aside. What other kinds of uses do you see for machine learning in the tools for thinking space? What else could we describe here that's a possibility?
I can talk about sort of a farther out one because it was something I was really excited about.
Love that. Please.
Still very excited about it. So give me the platform for it. So I think the other thing we can sort of think. So I talked a little bit about how do we start to connect this information automatically? How do we kind of push the creativity in that sense? That again is already here, right? Like it's already functioning in our product. I think it's like this is very much now. Moving forward, I think it's going to be very interesting when we start to bring in other types of data. So if we think about wearables, if we think about information about the individual as they're interacting with this information and as they're manipulating it, I am very excited for that. So one of the very early versions of Recollect was a little farther out there and was scaled back a little bit, but involves sort of could you bring in a brain-computer interface? I studied attention. So could you start to understand what people are attending to in these when they're thinking about things? How do you preference that information in these models, in these systems? But also, how do you catch when somebody's ready to do creative work or ready to do thought work? And how do you start to push them into that state if you want to or if they want to? And that gets into ethical territory. But I think there's a lot of opportunity in that sense once we start to combine really data from different places. So we can do this without a wearable to some extent today. If we think about interactions on your computer, what kinds of things are you reading? What are you attending to? Are they what's the sentiment of those things? But I think that'll be a big unlock when we get to a place where some of these wearables are more ubiquitous once we get that data. And then I think the other place that I'm very excited about, again, this is sort of an initial version of Recollect, but when we are using spaces outside of these rectangles. I'm very annoyed by the 2D-ness of this.
Mm-hmm.
I feel like, especially for abstract things, when we think about, I want to think about something, if it's hidden, if it's buried in a file structure, or I can't really see it immediately, it makes it harder to work with. So I'm excited about some sort of AR coming on that people can use more easily. Again, another thing I thought would be here already, and it's taking a little bit longer, but in that sense, you can start to think about, okay, if I'm building a tool for thought, can I start to put my memories places or things I want to think about in space, like I would a book or like I would pieces of paper that I put together? Can I start to alter the environment to facilitate that kind of thinking? So if there are associations that I've made and I've started to put those together. And then there's the obvious piece of can I manipulate things that are not hidden now? They're not just in this completely flat thing that I can't really reason about as a human who didn't evolve for all the stuff to be in the flat thing. So I'm excited about those two areas, but those are really, I think, going to require other technological advances before they're adopted by this community.
I love those ideas. Brief note on the second one you just posited, which is one of the earliest of these podcasts that I recorded was with Yiliu Shen Burke and John Underkoffler. And Yiliu is the founder of SoftSpace, which is busy working on AR, XR, VR, those kinds of things. And John Underkoffler was a name I didn't really know, but you've seen his work because in Minority Report, when Tom Cruise is doing the gesture interface to find to use precog information to find pre-crime, John invented that language, and it's a functioning language. He can actually, multiple people can approach with different devices, which sync up with a big screen, which then can be moved around, can be shared to other screens and across devices, and you can zoom and open and query with a language that looks like that. It's super interesting. So we had a good time with that. I'm not sure we answered that question fully because we did an hour or 90 minutes or something like that. So I think there's lots more to do in that area. I had a coffee with an engineer from Google Glass after Google had deprecated Glass, and I was really interested in the brain and a heads-up display, because if you could feed my brain my geolocation and identify a couple of things in my field of view, people or things, there is an awful lot you could do that would be super, super interesting, right? And we rapidly figured out that glass was never going to have the resolution to be able to display text like that in front of me. But then we had a really juicy conversation about what's the potential of augmented reality in space when you've got some kind of large memory with a lot of stuff that matters or that could be relevant to bring in. And I love that particular area. Other zones, or Sam, any comments on the ones that Alice just mentioned?
So those are great. I mean, I would say, I guess one near-term thing, which I guess is already happening, which is kind of interesting, to kind of like continue on with like GPT-3 and some of these language models, is the way in which people are using them to collaboratively write like stories and fiction and things like that. When so whether it's like pseudo-write or some of these other tools, I think there's some really interesting things happening there. Longer term, although I guess there's some near-term stuff happening as well, is around not just like tools for kind of helping us navigate, I guess, large bodies of knowledge, but also kind of helping tools to help us actually learn those areas. And so if there's, helping essentially a tool that would kind of adapt to the way in which each of us learn, as well as knowing the body of knowledge we already have in order to learn some new field of study or whatever it is, I think that'll be really interesting to see. And you see, there's already hints of like things around like spaced repetition, in terms of just actually like learning a new language and like making sure you're actually kind of learning that kind of stuff. But I think there's a lot of potential there in terms of using ML.
There's the scene in The Matrix where Trinity is in front of a helicopter and she calls Tank and says, I need to know how to fly this, and downloads the capacity to do that. I'm like, I want that. Yeah. I want to be able to do that. That sounds great.
I think that's nearer term though. I mean, if we look at today,
you think so?
Well, okay, so I'll posit one solution to that problem, and then
Please.
maybe it's wrong if someone actually tries to work it out. But if we have all this information about what we're consuming or what we know, right? So we have some, let's call it scaffolding, right? So we've got some basis for what somebody might know generally. And we know that one of the ways people learn best is when you apply something or you attach something to some structure in their minds that they already have, right? So if I am trying to teach somebody something, there are definitely, you're absolutely right. Like there's different ways that people learn, right? You can adapt things to be, more in the audio, more video, whatever. There's lots of ways that people learn best. And if we could say, take some text and generate a video out of it, great. The person gets something out of it. But I think even in a lower hanging fruit really is, okay, so we know this person knows these couple of concepts, probably a lot of concepts. Those concepts are a little bit fuzzy. They're not necessarily keywords, but we know that they have some information about those. Can we see how far away this other new thing is and try to see what the bridge is? Like, what are the things generally? And then language models would be excellent for that. So I think that's the way we can start to tailor learning today if somebody wants to build that in a way that would be really powerful. Of this other sea of information, if I want to learn something new about, cat species, there's lots of information out there. It's too much. I can't figure it out. Okay, find the stuff that's nearest to what I already know, and then use that as the bridge.
I was gonna say, it reminds me, actually, there was a paper that was co-written, co-authored by a friend of mine from a number of years ago, where he was taking different scientific fields and looking at the jargon, like the different kind of keywords and terms that are used by different domains. And then what he did was they created this essentially some sort of topographical map of different fields. And so it was the kind of thing of saying, okay, let's say you want to move from, I don't know, theoretical ecology to molecular biology or whatever the examples were. I don't remember exactly. It would kind of give you a map of saying, okay, you wouldn't necessarily go directly, you would go through these other fields because those are the ones that have the most similar language. And so I think what you're saying is exactly, there's a lot of similarities there in terms of how do people learn? How can we figure out what kind of concepts, what kind of jargon do people already have? Because jargon is actually a very problematic thing, because it's you might have the exact concept you need, but it's a very different term. And so you can't search for it and you don't really know even what to look for. And so having some tool that can kind of help you navigate and say, okay, this thing actually means this other thing that you already know about, but you don't realize that, can be very powerful.
I love that. Along the way, for what you guys were just saying, I was thinking, wouldn't it be cool if you could have some machine learning basically tell you what are multiple different connective paths between these two sets of ideas? Because it's one thing to say, what is the shortest path? What is the quickest way? What is the obvious bridge? It's another thing to say, hey, did you know these things are connected in these 6 different ways? Because sometimes it's the obscure or the less known path that actually opens a deeper connection or the right kind of answer or whatever it might be. And we don't have time permutationally to do it. Our brains usually can't handle like setting things aside in that orderly a way. And there's a whole lot of reasons why it would be hard for a human to sit down and do that unless that was the specific goal of their endeavor. But machines could probably do a very nice job of that.
I think that kind of comes back to those evolutionary algorithm point we made a little bit earlier around like what's the objective of this, right? If we say the objective is to find things that are less common, right? Let's find these paths that are not the most well-worn path, right? There's not the most number of connections between these, but maybe there are fewer. And then I think you're right about humans too, right? We aren't able to keep that many things in mind, and we think we can. We really can't.
We need an extended mind of some sort. Don't know why.
Yeah. But yeah, being able to play all of those and cut through a lot of the cognitive biases we have and our own attention, right? Like if I'm really focused on this thing, I'm really not. I mean, to be creative, you actually have to be mind wandering, which is a really interesting piece, I think. So if you look at studies of creativity, when your mind's wandering, it's not super focused. And so if we're really focused on solving a problem, we're really focused on finding a solution, we really cut out a bunch of the world necessarily. So we don't even if we could keep all those like 9 paths really in our mind, and we were like a super genius in that sense, depending on how long the paths are. I don't even think we would get there. So I think that's really another place we could bring machines in to help.
Anything else coming up for us? Any other? I mean, I had made a little list before the call. There's partly from what we were knocking back and forth. There's sort of the ideation idea. There's the idea of increasing serendipity or divergent thinking, divergent ideas. There's how to navigate through gigantic bodies of knowledge and make your way through, which we've talked about a little bit here. Suggesting connections or summaries or insights. That's actually pretty. Chris Pedregal, who was your interviewer in the panel at Render, the thing that caught us when we were talking with him sort of earlier was he had been taking audio notes, transcribing those, feeding those into GPT-3, and then querying GPT-3 about his own notes. And GPT-3 was doing a very nice job of summarizing things for him. And I was like, oh, damn. And he just hacked that together the way Linus was just sort of hacking things together for his own pleasure, right? Super interesting. And that sidles over into this idea of having space to play with these things, because I think a lot of the insights and a lot of the important work will be done by people who are just messing around, just taking some of these tools and recombining them and putting them in doing multimodal in some way that's unexpected, and suddenly it starts coughing things up, right? I think we have some of that ahead of us as well. There's an old Mac app that some people still like Stephen Berlin Johnson is a big fan of Devon Think.
Uh-huh.
Oh, yeah.
And what you do with Devon Think is you feed it a whole bunch of documents and it suggests connections. It basically has like a relevance or similarity ranking. I'm forgetting what the algorithm is that does similarity ranking, but and it's, been around forever. It's sort of a niche product.
Yeah. I think the summary thing is an interesting point. It's something I've been thinking about a lot in terms of these tools. So if I can just take this that direction for a second.
Please.
So we have this product now that is really powerful in that it brings all these things back for you that are related. It can bring things back that are inspirational. That's amazing. As soon as we made that true, I feel like I was struck by this problem again of, oh no, there's way too much information. I've got all this stuff. I've got it on my board. What do I do with it now? And so I am very interested in this idea in like probably maybe a little bit of a principled way of trying to figure it out. But how do we start to get this summary or this gist or this like TLDR for people around all of these disparate pieces of information, which is not an easy problem, it turns out. So I've been experimenting with some things, but it's really about, that is a place where we talk about, we want to get to human quality in a sense.
Right.
When we talk about a summary of something or like a takeaway. We don't want a thing that's like, what in the world is this?
And summarizing is both urgently important and very dangerous. Dave Snowden has a bunch of philosophies about data collection and the use of data and analysis. And one of his insights is you don't want people in the middle summarizing and collapsing the raw data to sort of tell stories or whatever else. You really want access to the raw data because the summarizing tends to really warp and bias things. But But at the same time, for reasons you just explained really nicely, we absolutely need something to digest, filter, synthesize, deglaze maybe these huge bodies of knowledge. One of my amateur design ideas about this is what I call levels of zoom.
Mm-hmm.
And so one of the reasons the brain works really well for me is that it has a pretty high level of zoom, but not the highest. The highest level of zoom conceptually is where you're up looking at the big ball of twine of entities and their interconnections. And I have never done that with my brain data. Don't want to, not interested. There might be a couple nuggets there, but the next level down, or maybe it's a couple levels down, I don't know. But the level that I'm at that I really like is that it's just words or phrases that are easy for the mind to parse because they're either up, down, or left, right. And that's the only set of relationships that are possible in the brain. That turns out to be a really nice organizing principle for how you parse visual cues and how you make sense of things. And so I get this very deep sense of orientation and local structure from that I don't get from other kinds of tools. And then if you pop down another layer of zoom, you're seeing summary paragraphs. This is a little bit like a stretch text that Ted Nelson invented years ago. And then all the way at the bottom is full bodies of text that might be linked up, might have context, might have tags or whatever, but the full text. And when I see the full text and I zoom out a little bit and there's no other cue levels at the zooms, I get lost right away because all blocks of text look alike, right? You start to just see a forest of blocks of text and it's like, oops, I just lost my ability to get around. I don't know what's where. And so how we mark up, navigate, mess with that. And some people are highly visual, so they'll like the visual display. Other people are not at all. They just want, show me all the things with this backlink and I'll be happy, right? Which is sort of Rome, Mem, Athens research, all of the outliners with backlinks are kind of in that category. And a long way of asking a question, but does that sound possible? What are your sort of approaches to solving these issues, et cetera?
I'm not sure I have a good answer for that. I think, and certainly one of the things that there are many different, exactly what you're saying, like there's many different ways that people kind of process lots of different information and like figure out kind of how to get the lay of the landscape while also kind of understanding the details. And certainly, like one of Linus's techniques of like trying to kind of put words in, either color them or kind of like provide them in some sort of like meaning landscape, I think is really powerful, because exactly what you're saying, Jerry, of like large blocks of text, you can't really get a sense of what's inside them without any, like just at a glance, because it just looks like words, and then without reading the entire thing. And so, yeah, and I guess one of the things, I'm not sure this is quite answering your question, but one of the things that it makes me think about is summary is right. It can be dangerous, but I think it's not necessarily summary that is necessarily the key. It's more about how can I guess delimit and limit the search space or reduce the search space of the things that are potentially relevant, and then still allow people to then say, okay, and rather than some massive high dimensional space that I can not possibly examine, saying, okay, here's the area that you should be looking in. Now, of course, it might mean because of whatever technique you're using, you're going to miss certain things that could be relevant. But at the same time, we need to be honest with ourselves that if we were doing it manually, we would also be missing things. And just because the algorithm is not perfect does not mean that humans in turn are perfect. We are all imperfect in our own special ways. And so, but I think if we can have tools that allow us to limit the search space and then allow us to kind of see what is the underlying data, that can be very powerful. So I'm not sure that quite went in the direction that you expected, but I would say that is the way I kind of think about some of these sort of things.
Yeah, thank you. That does harmonize well with what I was thinking. Alice?
I don't know if we've talked about this before, Jerry. So my team all knows about the octopus, or we tried to turn it into a forest analogy because no one liked the octopus. When I was starting or thinking really about Recollect, I was really frustrated by this idea that I didn't have the ability to change levels in sort of the way that you're talking about, but not in levels of the document, which it sounds more like you're talking about. I wanted to, first of all, create like a algorithms to pull out actual concepts for people and not just the words. But then once you have something in place, to have which is what we have right now in our product, which is like the underlying sentence or paragraph of information. You've got some information here. Up a level for me is, in a sense, that summary. So if I have a couple of these and they're connected, I want to go up a level. I want to just get like a summary of that going up. Going down for me, though, is not the full document. Going down for me is actually the individual sort of machine-generated concepts. And so I have all these drawings of this, and I tried to explain it to the early team when they were joining. And I was like, this is what I need. It's an octopus. It's got to be an AR at some point. And they're like, thankfully, they joined the team still. But I was like, I need to be able to be at these different levels for different things, too. So I need to be able to take sort of machine-generated, like, what are the components of this paragraph even? And I need to be able to move over to another, not octopus, but tree or branch, right? And be able to like see.
It's a mycelial root system with the flower. The paragraphs are actually flowering, fruiting bodies of the mycelium known as mushrooms. Those are actually paragraphs. See? How do you do that in software?
And now, I mean, there's this great radio episode about this, but now there are like in the canopy of trees, there's a whole nother canopy. There are trees growing in the canopy of trees way up high, all these plants. It's amazing. So maybe even more like that. But yeah, whatever natural reference makes sense for people, it's really this idea for me. Like it's about how, like it's in some senses a level, but it's not the level that whoever wrote the document made. It's mine.
Yeah, exactly. And there is a massive UI challenge here about how do you become aware of what's available? How does ML, machine learning, assist you in making sense of it and adding to it? How do you switch views when you need to switch views? Like there's some data is naturally 3-dimensional, or you can change n-dimensional, you can swap in dimensions, and then you should be in AR and standing in the data and looking around. For me, word spaces, concept spaces don't work very well in n dimensions. Like I need flatland to negotiate them usually, but not always. So how do I know when and where? In Apple's old Knowledge Navigator video, they had 3 little iconic assistants on the side that had different characters, different personas. I don't remember what they were. Let's call one like a professor, and one was like a researcher, and one was something else. And they would each kind of raise their hand or make a little gesture when they had something to say to you in this simulated user interface. Not a bad idea, because they could represent your preferred ways of looking at what you're doing. And then when one of them says, hey, right now, you would pay attention because they likely would have something really useful for what you're trying to get done. We're getting near the end of our time, and I just wanted to offer both of you like what questions would you love to see answered? Where might we all go next? It sounds like all 3 of us are pretty hopeful and optimistic about this space and happy to be alive at this moment because there's just so much going on. So I'm good on that. But what does the agenda? What was maybe the research or the design agenda feel like for you?
I mean, so for me, I guess I would just go back to like, how can we handle the increasing like burden of knowledge, both in the sense of that there's like so much to know, but like it's also the fact of like, how do we learn all this kind of stuff so that we can make advances at the frontier of knowledge? Like, and there's some papers talking about like the death of the Renaissance man, the idea that like no one can know all these different things because we now have to specialize more. And can we now use these kinds of tools to kind of overcome that and still allow us to not necessarily be Renaissance people, but at least allow us to stitch together lots of different domains of knowledge? And if we can do this within some sort of kind of computationally assisted way, I think we don't necessarily have to be stuck in like hyper specialization. We can begin to navigate lots and lots of different domains of knowledge in a productive and fruitful way, as opposed to just a sort of dilettante way. So that is the area that makes me hopeful, among many, many different ones.
Love that.
I love that too. I feel like I get this image of like not flailing around and like, you can be a polymath, I guess, today, but there is way too much information. So like, yeah, it'd be lovely. I love that future. For me, research agenda, what I want to see next, what I'll make true to some extent happen next in the world. I am really interested in this creativity thread. I don't think the applications we have now are the end of that, and I don't know what paths they'll take. So I'm interested to see sort of how those evolve. But I am very interested in this idea that we can take sort of personalize as an individual your knowledge, right? Like there is too much stuff in the world, you're exposed to some things, you get some piece of that world. Can we help the individuals to sort of get that information to them, which is what we're working on right now? But then in the sort of like co-creation space, what are we going to see in terms of not just text generation of like, oh, I could like have it write a thing for me. How is it going to help us to sort of like push our ideas forward, I guess? So I love your learning idea, Sam, and I think that's really awesome. I sort of want to like have a thing that pushes helps me to sort of push my ideas forward, but also helps me to utilize the knowledge that I already have that I kind of don't really have access to. So TBD on what the research agenda will be exactly for that. But I'm excited about this co-creation space.
Exactly. Me too. What you were just saying, Alice, reminded me of a video that I posted. It looks like back in 2016. It's called Why I Do What I Do. I think what I'm about to do really quickly is in there. And I basically say, thanks for clicking on it. I basically say Leibniz might have been one of the last people alive who was a polymath and who understood all the disciplines of his day and kind of had his head around everything anybody knew in Western Europe at the time. And I picture him as like standing in the middle of this vast plain where there's disciplines forming up. And then disciplines form up and they basically start to get competitive. And then there's too much to learn. So here's mathematics, here's biology, over here is the humanities and poetry and arts. And over here, all these different sorts of things form up. And we start to get the academy and all the ways in which we try to tackle the disciplines. And the way that a new person in the field makes their mark is they go out to the fractal leading edge of their discipline, pick a facet of the fractal face, the seam, and then say, no, it's this way. And if they're really lucky and have a big effect, then their discipline shifts toward, that sort of thing. Like Margaret Mead had a big influence. Franz Boas had a big influence. And they kind of turn their discipline a bit, but still mostly the leading edge is a way of absorbing new ideas and not shifting very much. It's a way of almost defending the discipline's barriers. And then I think the part that all three of us like is the interdisciplinarity. And one day it dawned on me that maybe Leibniz is not standing on a plane, he's standing on a sphere. And that all these disciplines are sort of pie slices going away from him, but we've passed the equator. And they're beginning to converge. And I was having the experience in talking to biologists and neuroscientists and computer scientists and philosophers. I was having the experience of having similar conversations with different jargon and different framing and different backgrounds. And so I started getting this mental model of, oh my gosh, we're seeing this convergence of ideas and things and so forth. And then this little explanation begs the question, so what's over here? And then I have another amateur theory of history that's the thing that's over here. It looks to me like yin and yang. And I'm borrowing yin and yang from Taoism, and I'm going to overload it a little bit. Yin is generally feminine, receptive, dark, earth energy. Yang is generally masculine, positive, active, bright energy. It's not that all men are yang and all women are yin, but every healthy entity needs to have yin and yang in balance. And what happens, the interesting things that happen are at the interface of yin and yang. There's a creative tension there. And my little amateur theory is that we've been suffering from a yang overdose worldwide for 300 to 3,000 years. That's somewhere along the line, yang won, and we ended up in a command and control, male-dominated. Like if you scroll back far enough, it's matriarchies everywhere. Everybody understands how to nurture the commons. There's a whole bunch of other ways of living together on Earth and being just fine. Thank you very much. And we killed those off, basically. Yang, when it won, had pursued a scorched earth strategy and got rid of all traces of yin it could possibly get rid of. Luckily, many of them have survived. And we are now in this like very interesting era where we can see sort of what happened. We're trying to piece the pieces together. But I think that we're busy renegotiating how yin and yang play in our lives. And we're busy trying to figure out what is the next platform that civilization is going to run on. Is it crypto DAOs with NFTs? I don't know. Is it Zuckerberg's metaverse? I don't know. I don't think so. But it's going to be something. And there's no promise ever as humans evolve that the next regime is going to be healthy for us or better. Like we've been through so many just dysfunctional ones. And my thesis here is actually a very pessimistic one. It's that for 3,000 years, possibly, we've been suffering from a yang overdose. Is not a good look for humans. But this whole little image of mine is like why I get up in the morning. It's because I think that the curiosity we're showing here in this call and the interdisciplinarity and the ability to find how these things tie together for good is what's going to help that thing come about and balance out.
I love that. I love the interdisciplinary piece of it too. I think one thing that I'll just very quickly say on that front too is like you have two people here who went an academic path in a really specialized field, and ended up following curiosity and passion to other places for other careers and doing other things. But I think that is less common than the alternative of like, oh, I'm going to do this very specialized thing and I will make a mark in this very specialized thing that I'm very interested in. And so I think some of the shifting, it's really at the institutional level, like I had to find this path on my own and it's not an easy one. But sort of like staking out a way that I could make what I want to see true in the world meant for me, like, I don't know, this seems like the best way for me to be able to accomplish that, even though there's a lot of stuff that's very difficult about it. So I think if we are to make a shift sort of in a different direction or to a more interdisciplinary place, I'll make a little call for like creating those spaces where people can be more interdisciplinary, but also deeply curious. And the rub there is always capitalism, I guess, where it's like, how do you make that actually into something that's real and productive and like, contributing? But yeah, I appreciate that on the call you've got two people that could have gone the other way.
And I sense that, like I hear it in your stories, and in that sense, exactly as you just described it. Thank you.
Yeah, I would add to that. Like I think, and when you're talking about like spaces for this kind of thinking, like when people want to do research, kind of knowledge creation, they're often shunted into like a few different kind of modes of like academic or corporate industry lab or whatever it is. But it's like a few points in what is really a very high dimensional space of potential institutions and organizations, and we need to explore that space more broadly. And I think you're beginning to see new types of organization institutions arise, but we need more of that, and especially ones that allow kind of more interdisciplinary thinking to actually be valued. So yeah, I totally agree with it.
Absolutely. Thank you. But I want to thank you both for this conversation. This has been super useful and interesting and fun too. Fun besides. So thank you. Thank you all for listening to Tools for Thinking, a new podcast that might just help you with your thinking, if we're lucky. If you're part of a startup in the sector, please knock on our door at betaworks.com/camp. Thank you so much for paying attention here.